There's a lot of different ways that topologies are set up. So let's talk about some of the topologies of how these different networks are set up. There are several common topology types. So let's take a look at what a bus looks like, what a star, what a ring, and a mesh topology networks look like. Then we're going to talk about the difference between a physical and a logical topology, and then we're going to get into some examples. So first up, we have a bus. A bus is one of the most simplistic ways of connecting different networking equipment. It's not always the ideal though. And this is the reason why, is because when you have a bus, you just have a bunch of devices connected to the same line and it's communicating across the same media. And so when you have it set up like this, when one device talks, everyone can hear. And so you have a couple problems with this. Number one, if two devices want to talk at the same time, a collision can happen. And once there's a collision that happens, they both got to wait a little bit before they can resend. And so it causes some confusion on the network. It's especially problematic when your networks get very large. The other part of this is there's security concerns, because when a device talks on a bus, then all other devices can listen in on that. And so a bus is one of the most basics and simplistic, and there's some problems with a bus topology type. Then we have the star topology type. The star topology type has some sort of central node to it where all these devices are connected to. So then all of the nodes are connected out from this central point, forming a sort of a star shape. Then we have a ring type topology. A ring type topology has all of your nodes that are connected in a circle. And so as data transfers, it transfers from one node to the next. Then we have a mesh. A mesh just means that every single node is connected to every other node on this network. And so if you follow this, all of these devices are connected to every single other device. Now this could get really complicated. The more and more nodes you have connected to this single network, it can get pretty complicated and could possibly be expensive as well. But this is really the ideal setup, is for every device to be connected to every device. It can communicate directly to those devices. And so this would be the ideal setup. There's just a cost factor. For that reason, a lot of times we'll see a partial mesh where not every single device is connected together, but for the most part, there's a lot of redundancy that's involved within your network. So one thing to understand about these topology types is it's not bound to any single layer. It can operate on multiple layers. So here's an example: is we could have computers that are all connected together using a ring topology type, or we could have a series of switches that are all connected together. Possibly we're intermixing two different topologies here too, because from these switches, maybe it goes out to the computers in a star shape from the switch itself, and the switches then are within a ring pattern here, a ring topology. And then here is an example of routers that are happening. Let's say we've got some sort of layer 3 network that's happening in a ring formation, a ring topology. Now, that being said, there are certain topologies that are more closely associated with certain networking types and certain layers. For an example here, we have computers all connected to one another in a mesh network. This gets really complicated the more machines that you add to it. And so for this reason, it's very rare, it'd be very rare that you found machines like this all connected in a mesh formation. Perhaps maybe if there was a bunch of servers that needed to be connected together. Switches, we see a little more common with that, because we want our network to be self-healing, and so quite often you'll see switches that are interconnected with each other, so that way it can pass information, usually to help facilitate if something were to go down, some sort of piece of equipment to go down, that it would still have connectivity one way or another. And we see that as we move up in the layers, here is routers that are connected. It's much more common common because that ends up being the backbone of our networks, and we want the most reliability, and we're willing to spend the most on the networking or this mesh layer of doing that with routers and our layer 3 devices. So another thing to understand about these topology types is there's a difference from a physical standpoint of how these nodes are connected together, but how they operate on a logical standpoint, or actually how it transfers data. The best way to illustrate this is an example. Here we have a hub that's in between these computers right here. This is set up as a star formation. It creates a bit of a star where there is a single line that's going out to each one of these machines. And so that is a star topology. Now, the way it actually communicates is this is a hub. And a hub has, we know that that's a repeater, and whatever comes into it on one port gets broadcasted out on all ports. And so it actually behaves more like a bus. So from a physical standpoint, we connect these computers through a hub with a star formation. But when you actually look at the data and how the data is communicating from a logical perspective, it's actually communicating using a bus formation. So let's look at another example of this. So let's talk about token ring, which is a ring technology, token ring. It's even in the name. And so what we might have is we might have a single device that's connecting all of these nodes, all these different nodes to this one device. So from a physical standpoint, it could look like a star formation. But the way token ring works is it has a token, something that it gives the right to each one of these devices a chance to talk. And so it starts out at one device, and then it moves on to the next device, and then that device has the chance to speak, and then it moves on to the next device, and it has a chance to speak. Now, this can be a really slow process, especially if there's lots of machines that don't really need to speak, but they're getting their chance to speak. So in this case right here, we don't see a lot of token ring anymore, but we still have ring networks that are out there. So now I have a question for you. I want you to think about what is the physical and logical topologies of a wireless network. Here I've got a wireless network. Think about a second of what is the physical topology of this and what's the logical topology. Okay, you ready? So if you answered physical would be a star, you would be correct. There is a central node here, and it communicates out with each one of these computers that are connected to it wirelessly. And so this is a star formation. Now the question is, what is the logical? How logically does it communicate? And this is a little tricky because when these devices talk, all other devices can hear and no other device can talk at the same time. And in other words, that this access point acts as a hub. It's a hub, and only one device can talk at the same time. So if you answered bus for this, then you would be correct. It talks, the way it communicates is more like a bus, but the way it's set up with these individual machines talking to the access point, it's set up more like a physical star. Now, there are some technologies that are set up both physically and logically the same way. There are bus systems where all of the computers are set up on a single line, a single media, and the way they communicate same way, because it's going through a single media, they all have to share that line, and so it's set up both physically and logically as a bus. One thing you'll want for your network is some sort of network map. Something that outlines how things communicate and how things are set up. Now, the trick is that you have both a physical way things are set up and a logical way that things are set up, and they could be very different. And so a physical topology and a logical topology map would look very different. So from a physical perspective, we have different buildings here. We have building A, B, C, and then we have some sort of annex building. Each one of those buildings has their own switch or set of switches within that building, and then it communicates back to one main network closet or one main network building. It communicates back to a central point here. For this annex building, we actually have a point-to-point wireless set up with it. So physically, we have all this set up, and computers could be set up different in each one of these buildings. But from a logical perspective, perhaps that's not how it's set up at all. We might have a network that's made for administration, so they have their network that they communicate on. We may have one for operations, so operations has their own network. Perhaps sales has their own network, and perhaps the servers have their own network. And what's tricky about this, which is strange, is you could have administration, you could have a computer in one building that belongs to administration and a computer in another building that belongs to administration. If you like my videos, could you hit that like button? Because it really helps me out. Thank you. So, and then same thing with operations. Maybe you have an operations laptop down in building C and an operations laptop in building B. The way they communicate, they all communicate within that operations network, even though they're going across the same physical switch or different physical switches. So your physical network could be set up much different than your logical setup. And so therefore, what you probably want to do is have a network map that represents the physical topology and a network map that represents the logical topology. So there you have it. You have different topologies, which is bus, star, ring, and mesh. And then of course you could have a hybrid mesh, but these represent multiple different layers. They also represent both physical and logical networks.